Hey guys, welcome to our new lesson. It is on Scatterplots. This is 9-9 Part A. We're going to be doing this lesson in two sections. So we've got an A and a B for this one. And the objective for both parts of the lesson say that it's to learn to create and interpret scatterplots. Today's lesson is going to focus more on the learn to create and a little bit on interpreting, but but the next lesson we'll really get into interpreting what those scatterplots mean. So the first thing that I want to do is go over some new terms. Scatterplot might be a new term to you, but it hopefully is review. A scatterplot, though, is going to be a graph with points plotted to show a relationship. So keyword is relationship for this. And it's going to be between two sets of data. So on one axis, you'll have one set of data like money. I don't know, I'm just making something up. And on another axis, on the x-axis, you might have like time. And then correlation is a new word for you definitely. Correlation is going to describe the type of relationship. So it's going to describe whether it has like a positive correlation or a positive relationship or a negative. And I will explain what those mean. So when you look at this set of data, do you see a trend? Can you notice any type of trend? So you've got dots that are kind of just scattered. That's why they call it a scatterplot. But you want to kind of look at like the shape of the data. So the shape of the data is right here. What scatterplots do is they provide a convenient way to determine whether a correlation exists between two sets of data. So the missing term here is correlation. So do we notice a trend here? Hopefully you should notice a trend that the shape kind of takes on, or the shape of this data kind of takes on this type of a line. So this is going to be called a positive correlation. So positive, meaning that it goes up. Here you can see the positive. This is a strong positive because all the numbers are really close to the middle line. And then this would be like a weak positive because while all of them still have that tendency to go positive, the number or the data kind of strays from that middle line. So a positive correlation occurs when both variables increase at the same time. So this word down here should be increase. So as one increases, the other increases. So the opposite of positive correlation is going to be negative correlation, and negative is going to have a more downward slope. So here is a weak correlation where the numbers for data are kind of far away from the middle line, and this is a strong correlation where they're nice and close. But a negative correlation occurs when one variable increases and the other variable decreases. So when they're doing opposite. So this could be increases while the other variable decreases. So what happens if you just have data kind of like scattered everywhere where it doesn't look like they're going up and it doesn't look like they're going down? This is called no correlation. So no correlation is when the data points are randomly scattered. There is, sometimes people call it little, but most of the time they'll call it no correlation. Little correlation or no correlation. So here's your first example. I want you to go through A, B, and C, and I want you to tell me what kind of correlation each of these examples show. So letter A, letter B, and letter C. And you need to write your answers down on your notes. Number 2, we're going to do together. This is giving us examples of scenarios, like things that could be happening in real life, where we're going to match it to what's going on the scatter plot. So for number 1, we want to say we're comparing like the age of a person and their height. So when their age is really young, is their height going to be really low, or is it going to be really high? And then as they get older and older and older, what happens to their height? So for age, I don't even have a good spot. I'll just do it off to the side here. For age, as age goes this way, so we're young. When we're young, our height is not very high, so we're down here. We get a little older, we grow a little bit, and then as we get older, it kind of goes up, up, up. So the graph that's going to match is going to go with a positive correlation, so it's this one right here. So we'll put that with number 1. Then let's look at number 2. Number 2 tells us that it's going to be a situation where we're comparing our age with our eye color. So we could take data from like a little 1-year-old, and they might have green, different ages, and these are basically going to be all over the place because there is no correlation between your age and what your eye color is. So this would go with number 2, which kind of makes the last one easy, but I want you to see why. So for number 3, your age and the time needed to run a certain distance. So when you're little and you can't walk at all, like it would take you a really long time to run like a mile. And then when you're like 3 years old, you're starting to get better and a little bit quicker and your time comes down. But as you get a lot older, you'll really see a decline. So that's going to show a negative slope, so that's our 3rd. Okay, this is a you do number 3. I want you to analyze this situation. Think about the distance covered and the time that it takes at a constant speed. So for your graph, you're thinking about time down here, and then distance as you go a certain speed. So decide if that's going to have a positive, a negative, or little or no correlation. And then here's another one for you to do. I want you to try this one on your own also. You're going to compare the value of a used car and the total distance that it's traveled. So value versus the distance that it's been driven. So as you drive a car, what happens to the value of that car? You're going to decide if it's a positive, negative, or no correlation. Okay, next is a we do. Number 5 is a we do. So we just did a little bit on interpreting scatterplots, but before we can really start to interpret scatterplots and use them to make predictions and stuff like that, we need to first kind of practice and learn how to create the scatterplot in the first place. So you're going to make scatterplots, you're going to be given some data, and it's going to look just like an XY chart that we've kind of been messing with as we've been doing slope this year. And you're going to take those points like an X comma Y. So for this one, it would be like height in inches would be our X, and our weight in pounds would be our Y. And we're just going to plot them like they're coordinate points. So this is for each member of a basketball team. And then after we get these plotted, we can describe the correlation. So we'll worry about that at the end. But let's just go through and start plotting these points. So we've got a basketball player for this first one who has a height of 71 inches. So we're going to find 71 inches on our x-axis, and his weight is 170 pounds. So we need to kind of figure out where those 2 points meet, and that is for our first basketball player. So it's just like you're plotting on a coordinate plane. Okay, next I'm going to go to 68, 160. So I'm going over to 68 and up to 160. I'm going to put another dot there. My third player is 70 inches tall, so I'm going to go over to 70, walk to 70, and then I'm going to ride up to 175 pounds. 170, 75. That actually should be a little higher, I think. There we go. And then we have 73, 180. And our last person is 74 inches tall, and he weighs 190. So now that we have our scatter plot created, that's how you create it, you want to take a look at the pattern of the data. So you can see that it kind of has a slope that's going up a little bit. So this would be called a positive correlation. So that is how you would create a scatter